Hello. If you want to learn about the repository pattern, or if you've already seen and used this pattern and just are interested in hearing someone else's take on it, stick around. That's what we're covering in this video. Okay, the repository pattern. This actually stems from a real-world scenario where my team recently embarked on a pretty ambitious journey to cover 3 of our major business initiatives for this year. Given the complexity, we chose a microservices architecture, or actually maybe contributing to the complexity, we chose a microservice architecture. Yet we really needed to scale horizontally based on load, and we wanted to break our team into squads so that we could effectively tackle some of these issues. The divide and conquer method. Well, we found over time that we were making quite frequent changes to the schema. And every time you make a change to the schema, if you've got a backing database, you have to create a migration, you have to apply a migration. And this cumbersome process became even more so given that we take our workloads, shove them in containers, and orchestrate the deployment of those containers with Kubernetes. And one thing led to another, and we had Kubernetes running locally on our machines. This just culminated into a disastrous process where we wasted a lot of time dealing with migrations. And in the early stages of a product or building a product, you really want to iterate incrementally. You want to move fast. You're making lots of changes because you're learning lots of things about your models, the entities, and when you've got something substantial, the aggregates that consume those entities. Well, that toil ultimately led to us implementing the repository pattern. And let's take a look about what the repository pattern actually is, answering some questions. Really, does your API store data? And do you need a layer of abstraction? If those 2 things are true, then perhaps you need the repository pattern. And at its core, it's just a data store. How does it work? And why do we care? The repository pattern describes just behavior, not implementation details. And let's say you have an interface. That interface has a method signature or method set, a set of things you can do, a contract, an API contract, where consumers look at it and they have a pretty good understanding of what they can do with your service. Well, you can say you want to add a thing or update a thing, delete a thing, basically CRUD operations, right? Well, let's say in the early days of your project, you don't yet even know what backing database makes sense. Well, during that time period, you can create an in-memory data store that satisfies the interface. And this allows you to make those rapid changes to the schema, and that's not indicative of every project, right? There are some times where you have all the details up front. You don't need to make migration changes or schema changes all that often. Hey, if that's the case, if that's your use case, it's probably not a hard requirement to use the repository pattern. Although I still would argue that just having that interface there gives you space to make changes in the future. For us and our team, we really needed to leverage the capabilities of the repository pattern. It unblocks us. Now we just make changes to our models and we don't have to worry about creating migrations and applying migrations and just dealing with the persistent data store in general. And then later on, when you're ready to go to production and you have a good idea of what backing database makes the most sense given all of your hypotheses and experimentation, then you can pick a backing database. And moreover, in the future, maybe you realize, hey, we picked a relational database, but given the schema changes, perhaps Mongo or some NoSQL key value pair store makes more sense. Really what we're talking about is programming versus engineering. As you're iterating and moving fast, you're programming, like just getting things done, vetting out your ideas. And then in the future, hopefully you have cycles where you just refactor, and this is engineering. You're making your ideas concrete, solidifying the engineering practices, putting together workflows to how to make your team more effective, and documenting your standards, the design, the software engineering, software architecture components. Dealing with the minutia and the bureaucracy of relational database schema changes in the early stages of a product, especially one really big where you're even perhaps dealing with junior engineers who are still learning how to do design in general or build a brand new thing from scratch. It can be a daunting task, and it can be a time waster. So let's take a look at a visual here. So we've got a service, and this is also another pattern, dependency injection. We're wiring up our repository into the service, but in this talk we're discussing the repository pattern. So here's an interface, a couple of methods that you would tie to an interface: new device and get device via IP. Well, as long as our in-memory data store satisfies these methods, we can plug it into our repository, and in the future we can unplug it when we're ready and wire up Postgres. Or like I mentioned earlier, maybe we unplug Postgres in favor of Mongo. Having the repository interface there and using this pattern gives you this flexibility. All right, with all that said, let's now take a look at some code. You can pull down this GitHub repository. It's public, it's on GitHub, like I mentioned. There'll be a note in the description of the video. Pull it down, fork it, play with it, do whatever you want. It's got a README file. And if you have any suggestions on how to make it better, add those too. But let's take a look at our interface. I'm just going to pull it to the side here. Let's go to store and repository. Repository, it's an interface. It's got two methods, much like the ones we saw, or exactly like the ones we saw in the drawing. New device, which takes in a new device, that's a new device request, and it returns a device and an error. Get device via IP takes in an IP address and returns a model, device, and an error. Let's first examine our in-memory implementation. And if I just, collapse everything here, our in-memory store, which takes in a map, which has a primary key as an integer and returns, and the value is a device. A device has these fields, these attributes. Count here, this is something specific to our in-memory data store, because we don't have a database schema where we would say, here's an ID. The ID is the primary key, serially incremented every time a row is inserted. We need some way of keeping track with where we are, how many devices we've added, and their position in the map. Because a map, especially in Go, has no order. In fact, in Go, not sure exactly which version of Go, but they realized that there was some kind of order to it. They made it completely random now in the interest of security. In my opinion, it's probably a good idea. Slight tangent. Now let's take a look. We have a factory function, or it uses a factory pattern here. It just gives us a new store, and it returns a pointer to an in-memory repo. Store takes or uses make, which just builds us an instance of a map, and then we tie our store, the map here that gets created on line 22, and add it as the store field in our in-memory repository. Here are our two implementations of new device and get device via IP, are the two methods. I'll go ahead and collapse all that stuff or expand it. New device, same signature as before. Here we're just instantly counting or incrementing count, and because we're using the nil value, this is going to be 0. The first time this gets called, it'll be 1, and then so on and so forth at each subsequent call. I have a little helper function here that just ties the attributes here in the new device request model to an actual device. And then we set the count that we incremented here to be the ID, and then we update our key value pair, our map, returning the device and nil. Get device by IP takes in an IP address. Here, we're just setting a value of match to an int. This will be 0 because we're using the nil value of an integer. We're looping over the key value pairs, and we're just setting those temporary variables in the loop to pk for primary key and dev for device. Ranging over our store, if IP matches the device IP at each iteration through the loop, we set match to equal pk. If match is 0, when we get to the end of the loop, we just return an error, device not found, and the nil value for a device. Otherwise, we return the matcheth position in our store and nil. This is beautiful and allows us to just deal with our models and not worry at all about the data store. And when we're ready, we can implement something like pg.go here, where we're defining a pg repository, which is a struct that has one field, database, which is a pointer to a SQL.db. We use the same type of pattern. We've got a factory function here that spins up a new instance of a pg repository. This time we do have some input parameters. We need a data source name so we can connect to the database. And that's what this factory function is doing here. Rather than spinning up a map or creating a map, we're connecting to the database and ensuring that we can connect to the relational database management system, as well as talk to that specific database with a pinger here. And then we just return a pointer to our PG repo, setting DB to DB. We have the two methods that satisfy our interface. Let's take a look at those implementations. We have a query here. We're just inserting one row, and we're using a context, also a really cool feature of Go. This will time out and gracefully spin things down if we go 5 seconds without talking or getting a response from the database. And here we're just inserting the row. Get device by IP, this is another query where we're using a select statement as opposed to an insert. We're asking the database for a row given our criteria here. Does IP equal IP? And if so, we scan the row attributes or fields into our device that we instantiate here. And then we return dev and nil if this succeeds. If it fails at any point, or really right here, we're returning the nil value for device and meaningful error message. This could be improved, right? We're turning the low-level message. We could wrap this with something that says, I couldn't get device by IP address, but this is just a tutorial illustrating the benefits of the repository pattern, not how to properly deal with errors. Although, if you're so inclined, you can update the repository, submit a merge request, and I'll make it better. Let's take a look at how we use this. Let's go to the service. In the service, we're also using an interface here with the two methods that correspond to the methods on our repository. This is what gets exposed. No implementation details, just behavior. Here's our service, the concrete implementation, where it has one field, a repository, that takes in our store repository. Again, no implementation details, just behavior. Here's a factory function that spins up the service, tying the repository that gets passed in at creation time or at runtime, and we feed our repository into the repo tied to the service. We have our methods here, where at the moment we're not doing anything before and after. We're essentially just dipping into the repository and calling those methods. Let's take a look at this in our experimental.main Go file. Initially, like I said, we're playing around with an in-memory data store. Or not, like I said, here initially we're using an in-memory data store. My team actually did the reverse here, where we used a Postgres instance first, and then we swapped it out with an in-memory data store, which at some point in the future we'll switch it back once we're done iterating. Let's see, we stand up a new repository using a factory function, and then we call new service, passing in our repository, and then the stuff that you'd expect, right? We add a new device, we get device by IP, we're just testing around. We can actually run this code. So let me clear this out. We'll say go run command experimental main.go, and voila, create a device successfully. The PK is 1. And here's our handiwork where it's just printing out the fields. Now let's say we want to swap this thing out. I'm just going to come up here, we'll do some live coding. I'm going to just remove this one line. And actually, I'm just going to remove that one call, and let's say create the Postgres devices store. And new PG repository. This wants a DSN. We'll say DSN here. This does return an error potentially. Let's go ahead and define our DSN. I set up an environmental variable, or maybe I didn't, maybe I'll do it in a second, for DSN. I'm going to save the file that pulled in the OS package. Let's quickly make sure that that variable exists. It does not. I'm going to open the README file, and where is it? There it is. I'm just going to copy this, paste it in. Now we have our data source name as an environment variable. Let's come back over to main. We have our DSN, we pass it in. We're assigning an error value to the call to store that new PG repo. Let's deal with that error. So if error does not equal to nil, we're going to log it. And if this fails, it's pretty much the end of our execution. Let's bail, get out of there. So what are you complaining about? If error does not equal nil. All right, nothing else changes, right? Everything downstream stays exactly the same. Well, let's test this thing out. Let me first have a make file. Let me clear the DB. It's not running. Well, let's fire that up. I think I have a make for that. DB up. The container is already in use. Let's make DB down, DB up. Okay. Now let's run our code. Go run command experimental main.go. Does not exist. I'll get there eventually. Let's see, db all up. All right, let me do db down now. Sorry, I'm fumbling. Actually, well, you'll be able to use this whenever you download the repository. All you need is Docker, and you can run all these commands. So let's do all up. There we go. We're giving ourselves a little time for the database to stand up. And you can see here in the logs, we created the database, which that's what I was complaining about a minute ago. And we added the tables. Now let's run our code. Okay, cool. Created the device successfully. The PK is 1. And look at our handiwork. Awesome. So let's recap what we covered in this video. We walked through the repository pattern, what it is, how it might be useful, a real-world example from an issue that my team just recently hit. You saw some code. Feel free to download that code and play around with it, break it, submit a merge request to make this repository better. Hopefully this was helpful, and have a great day. Cheers.